Students, I am Assistant Professor Aparna Kedari. In this video, we are going to study aromatic and heteronuclear aromatic compounds. So let's start with aromatic compounds. Aromatic compounds is large class of unsaturated organic compounds which shows unique stability referred to its aromaticity. In modern instrumentation, nuclear magnetic resonance NMR studies are most likely indicators for aromaticity. Then the countable characteristic features towards the compounds to be called aromatic. The first feature is an aromatic molecule must be cyclic. Second is the aromatic molecule must be planar. Third, an aromatic ring must contain sp2 hybridized carbon atom that can form delocalized system of molecular orbitals, that is uninterrupted cloud of its electron above and below the plane of ring. Then the compound must obey Huckel rule. So statement of Huckel rule, it says planar, cyclic and completely conjugated hydrocarbons will be aromatic when the ring contains 4n plus 2 pi electrons. The number of pi electrons in delocalized n system must equal to 4n plus 2 pi electrons, where n is the integer. So moving towards the classification of aromatic compounds. Aromatic compounds are classified into benzenoid compounds and non-benzenoid compounds. Benzenoid compounds mean that this compound contain at least one benzene ring in their molecule. Then non-benzenoid compounds, they are aromatic but they do not contain benzene ring in their molecule or structure. Then benzenoid compound again classified into monocyclic, polycyclic, polynuclear, fullerenes and nanotubes. Then non-benzenoid compound, monocyclic means monocyclic compound means they contain only one benzene ring. Polycyclic means they contain two or more polycyclic benzene ring in the structure. Then fullerenes and nanotubes. The non-benzenoid compounds again classified into three, that is heterocyclic compounds, anilines and aromatic anions and cations. These aromatic anions and cations are also aromatic in nature. Heterocyclic compounds means they contain heteroatoms like nitrogen, oxygen and sulfur. Anilines. Then next is the benzenoid compound. Benzenoid is a class of organic compound with at least one benzene ring in their structure. These compounds are associated with the presence of one or more fused or isolated benzene ring and their derivatives. Benzenoid compounds are classified into three groups of compounds. First one is monocyclic, polycyclic or polynuclear fullerenes and nanotubes. Then monocyclic compounds, the cyclic compounds which only one ring formed by the same atom, that is carbon atoms, and which contain conjugated double bond system that obeys Huckel rule within the ring, are said to be monocyclic aromatic compound. For example, benzene, a six-membered planar fullerene conjugated carbocycles which obeys Huckel rule is known as benzene molecule. This is well-known example for monocyclic aromatic compound. It is represented by Kekulé structure. Then here the Kekulé structure of benzene. Due to aromatic nature of benzene, all the carbon-carbon double bonds in benzene found with same length, that is 1.39 angstrom. This value is a value in between that of carbon-carbon single bond 1.2 angstrom, 42 angstrom, and a carbon-carbon double bond 1.34 angstrom. In case of benzene, 6 pi electrons obeys 6 pi electron, that is 3 double bonds. Each pi bond contains 2 electrons, therefore total 6 pi electrons obeys Huckel rule, that is 4n plus 2 pi electrons is equal to 6 pi electrons and n is equal to 1. Hence benzene is cyclic, planar and it is also conjugated, and therefore it contains 4n plus 2 pi electron, therefore benzene is said to be aromatic in nature. Then polycyclic benzenoid compounds, the cyclic compounds that contain more than one ring formed by the same atom, that is carbon atoms, having conjugated double bonds and obeys Huckel rule, 4n plus 2 pi electrons. Within the rings are said to be polycyclic compounds. For example, naphthalene, anthracene, phenanthrene. This class of compounds are also called polycyclic aromatic hydrocarbon. These compounds present the examples of compounds where two or more benzene rings fuse together. Depending upon the number of benzene rings fused together, they are further classified as bicyclic, tricyclic, and tetracyclic benzenoid compounds. These are the examples of polycyclic aromatic hydrocarbon, that is benzene. It contains 6 pi electrons, cyclic, planar, and conjugated. Therefore, benzene is aromatic compound. The second example is the naphthalene C10H8, that is 10 pi electrons, N is equal to 1. Naphthalene C10H8, 10 pi electrons, N is equal to 2. It is also been aromatic compound. Then anthracene C4H10, it contains 14 pi electron, cyclic, planar, and conjugated. The next example is phenanthrene C4H14H10, 14 pi electrons, N is equal to 3. Then pyrene C616H10, it also contains 14 pi electrons, it is aromatic. Then benzo alpha pyron, the C20H12, 10 pi electron. Then dibenzo pyrene, that is C24 H14, 10 pi electrons, and it is aromatic in nature. Then structure fullerenes. Uh, Fullerenes, that is W. Kratzmer and Hardy Hoffman and co-workers in 1990 reported the first practical synthesis of C16, which looks like a soccer ball and also called Buckminster C16, is member of existing new group of aromatic compounds called fullerenes. Fullerenes are cage-like molecules with geometry truncated icosahedron or geodesic dome. It is named after the architect Buckminster Fuller, who is renowned for his development of structure with geodesic dome. Then Kroto, Curl, and Smiley, Nobel laureates, 1996, for their discovery of new fullerenes, found both C60 and C70 as highly stable components of mixture of carbon cluster formed by laser vaporizing graphite. The next is the nanotubes. In 1991, Lizima discovered a complex elongated type of fullerenes, the carbon nanotubes. Carbon nanotubes are composed of cylindrical graphite sheets. Like graphite, carbon nanotubes are also composed of sp2 carbon, meaning that each carbon is engaged with single carbon-carbon double bond, two carbon single double carbon-carbon single bond. Therefore, carbon nanotubes like graphite, pyrene, coronium, and many other hexagonal systems immersed into the sea of electrons are benzenoid system. Both nanotubes and graphite sheets are benzenoid derivatives composed of sp2 hybridized carbon atoms arranged in hexagonal passer. Both systems are aromatic in nature.